Right, yeah. Conjugates, right? Difference of squares, factors to conjugates. So I factored and locked it up. Okay? So my second and longest step is still very organized and efficient. I rewrite the problem with longer fraction bars, and all the denominators have been fully factored and locked up. Now I can see, now I go to the side, and I can see what my LCD is. What is a unique factor? It doesn't need a square because
it doesn't change it. It's not square.
Yeah. It's used at most one. Yeah, you see it twice, but it's used at most once in any particular denominator. What's another unique factor? Yeah, right. And so there, you see 4 factors here, but there's only 2 unique factors. Okay. So that's your LCD.
So we can automatically write that as the denominator.
This is our, yes. Now we need to make each of these denominators, each of these 3 denominators match that. What would make this match it?
If you add that x plus x minus.
Yeah, and careful, it's multiplying. You're tacking it on with multiplication, so you multiply it on top also. Here.
X plus.
So immediately do the same thing on top. Here.
You need both of them.
Does you have both of them?
Yes, ma'am.
Does it match?
Yes, ma'am.
So, yeah, so don't put anything else on it. It already matches.
Oh, because it would just cancel out anyways, right?
Yeah. And then also then it wouldn't match. Okay. Now, we have a common denominator. We're done with the denominator. The denominators were fully factored and made to match. So I go off to the side, and my final answer is going to have x plus 1 times x minus 1 as the denominator. And I just have to figure out my numerator. So now I just lift off, try and do this step mentally, just lift off your numerator, 7x times x minus 1 plus 8 times x plus 1 minus 14. I'm just combining this plus this minus that. Clean it up. Kill the parentheses with distribution or foiling, combine like terms, and then factor if possible.
Oh, okay. You just stream all like this.
Now you don't want to have to do all of that work while still dragging along your common denominator. So that's why as soon as you have your common denominator, set it aside, bring down your numerator. Clean it up. Kill parentheses, combine like terms. This is what I got. And before I put it on top over here, I need to fully factor it if possible. Okay, well, no GCF. I do have an A not equal to 1 quadratic trinomial. I know, right? Okay. These are skills you already have, but if it makes your heart race a little faster, that means it's a skill you need to continue practicing. Okay. Once it's cleaned up, I see I have a quadratic trinomial. I checked for a GCF. I don't have it. It's quadratic trinomial, A not equal to 1. ACB, but I'm not done. Because when you have A not equal to 1, ACB, but you're not done, your magic pair of numbers is your split middle. My split middle, my variable is an x, so my magic pair of numbers becomes 7x and negative 6x. That splits my middle into negative 6 and positive. I put the negative first and the positive second so I could keep a plus in the middle since I had that choice. 4-term grouping. Little GCF, big GCF, done.
Oh, so that's
But now you
top
can
one
start
is
can-
from you canceling, right? You've already canceled the common top and bottom.
Not yet.
No, I just took my numerator. Once I had my LCD, I set the LCD aside, and now I brought my numerator here and I'm cleaning it up. This is where all your work is here, is once you've found your common denominator and made it match, set it aside, now just deal with your numerator. Now your numerator needs to be cleaned up, combined, and if possible, factored. And factoring may require whatever of your factoring skills it requires. This is an a not equal to 1 quadratic trinomial, so it requires A, C, B, and grouping. 2 steps. And sometimes the factoring is really basic and simple. Sometimes this is the most tedious and messy factoring. Regardless, your numerator needs to be cleaned up and, if possible, factored.
So when you write that over your denominator, you're still going to have to cancel. You can cancel something.
Right. Now that everything's factored, I write it over here, but before I walk away, if you just wrote 7x squared plus x minus 6 over the top, that's not mathematically wrong, but it's not finished. Because until you factor it, you don't see if you can put it in simplest terms. 7x minus 6 over x minus 1 is actually your final answer. I still set this aside so I wouldn't forget my denominator, but I was able to put in lower terms.
Then the first time you put the 7x squared and minus the 6x, was there a squared on the other side?
Over here? Because all...
No, the other side.
Here?
On the other side.
No. Here?
No.
Sorry, okay.
No. You were on the right one the first time, but it's just on the left side, right?
Here.
Why is there a square on the left right there?
Right here? Because the GCF is x. They only have 1 in common. I GCF'd out. I divided out an x, because this doesn't have an x squared. So the most x's I can divide out is a single x.
So why did you leave that square?
Why did I leave what square?
The 7x squared when you wrote another 7x.
Because this 7x, I turned my trinomial into a 4-term. All I did was I keep the first term and the last term. I just split my middle term according to what my magic pair of numbers told me to do. Huh? And because those are both 7s, it's just coincidence. It doesn't have anything to do with, yeah. Okay. That would be like the messiest and tedious one you would see. But the point here in doing this is that you still have to have those factoring skills. Okay? That's something you already have, but may need to practice more. Because you should look at that and go, okay, no problem. Yeah, it's tedious. It's the ugly one to factor, but you can do it. Okay? You know how to do that, and you must do it in order to get your answer in final terms. And you might come to that, and when you try and find your magic pair of numbers, you're like, oh, there's not a magic pair of numbers. Oftentimes you get there and it's like, oh, that's just prime. I mean, I can't go any further. If you can't find a magic pair of numbers, then you can't factor it, and then you would just write that on top and be done. If you can't factor it, just write what you have. Okay, you go as far as you can. If you can't factor it, you're done, put it there. If you can factor it, you must factor it, then put it there. Okay? And a lot of times you can't factor it. This one was factorable. Okay.
Wow. So are we going to get problems that are that complicated?
Yeah. You're going to see 1 or 2 like that on the homework. Yeah. And there may be 1 on the exam. Yeah.
It's going to be more complicated.
Yeah. Most of them will not be, but there may be 1 or 2. Yeah. On the exam, at most 1 that ugly. Okay. On the homework, you might see 2 or 3. It's a good chance to practice all of those skills put together. Yeah. But no, your entire exam is not going to be ones like this. No. But you need to understand that tackling this is the same set of strategies as tackling any of them. Okay? The rules, the mathematical rules, are all the same. Okay? As it gets more complex, the rules are still the same. Okay? That's the nice thing about math. You're not having exceptions to these rules. Okay? Anyway, that's driving me crazy. Okay. All right. So, let's try. 5 over 3x minus 6 minus x over x minus 2 plus 3 plus 2x over 5x minus 10. Take a breath. These do, as I warned you at the beginning, these problems look messy and intimidating. This one actually isn't. It starts off looking big and messy and intimidating. If you keep your organized strategy, this one is actually quite tame. Okay? Trust me on that. Breathe. first thing, you note it's addition and subtraction, so you need common denominators, which you do not have. So rewrite your problem. Don't skip this step. Rewrite your problem with a longer bar and each denominator fully factored and or locked up. That can have a GCF taken out of it. Okay. Minus. Well, nothing to factor there, so I'll just lock it up. Okay. Plus 3x plus 2x.
Factor where? Oh, because you already have it there.
Yeah, it's linear. There's no GCF and it's linear. Okay. This one is also linear, but there was a GCF, so I pulled that out.
Okay.
This one, now I'm not going to factor any of my numerators, but I will, as a rule, lock them up if they're a binomial, because I'm going to be, any operation before them, I'm adding or subtracting that entire thing. So lock up your, don't factor them, but lock up your numerators. But denominators must be fully factored, because your LCD is a product of factors, so you must have a factor. So all your LCDs are basically being factored and locked up. This has a GCF. Okay.
What happened to the 10?
I factored it out. Divided them both by 5. Factor out 5. Always do a double check with distribution. 5x minus 10.
Oh, you're dividing it out.
Yeah, just like this is 3x minus 6x. That's what GCFs are, is dividing out a common factor. So it didn't go away. It's put in front, and you can remultiply, redistribute to check that you didn't change the value. Okay? Now that I see that longest step right there, but everything is nice and clean, fully factored and locked up, I make a note of my LCD, because now I can clearly see my LCD. Now first deal with, like I said, remember free-floating numbers like we did 5y and 6y? I'm not talking about the numbers that are locked up in parentheses, but do you have any numbers outside of the parentheses? Right. Right, so the outside you have a 3 and a 5, so treat those just like denominators. If you had 3 and 5 as denominators, what would your LCD be? 15, right. Huh? Look at the biggest one, 5. 5 is not a multiple of 3, but if I count by 5s, 5, no, 10, no, 15, that'll work.
And you're going to put the x minus squared?
Yes, x minus 2 x minus 2 is another unique factor. Yeah, I see it 3 times, but it's used at most once in any denominator. Huh?
Okay.
See, not so bad? Huh? Now that I found that LCD, okay?
But what about the middle one? It doesn't have to.
It doesn't. Not all of them are going to have the same thing. This might have just had a 15 instead of an x minus 2. Not all of them are going to have. That's the whole point. They're not common denominators. But we have to find, once we fully factor them, we write down our LCD as every unique factor we see, whether it's in one or more of them. It doesn't matter. Okay? And so our numbers would give us 15, and then we have an x minus 2. If there was a different binomial, that would also be up here, but there's not. Okay? But now we have the LCD. Now we are able to, each of these is either equal to the LCD or less. We're going to multiply each of these up to match the LCD. If they're not already matching that, we need to multiply them up to match it. So if we have 3 times x minus 2, or x minus 2, how are we going to make this look like 15? Right, times 5. So we do times 5 up here. How will we make this match that?
X squared, or x minus 15.
Times 15. See, we just need a 15 in front. So we multiply this times 15 also. Now this is 15 times x minus 2. This is 15 times x minus 2. What's missing here? Yeah. Now we have a 15 times x minus 2, and as long as we multiply this times 3, see, we already locked it up. If you weren't careful, if you didn't lock up this numerator, what would you be multiplying the 3 times? You're multiplying the 3 times the entire numerator. That's why you don't factor the numerator, but you do have to lock it up. Because you have to multiply something times it, it's got to go outside those parentheses. Very important. Lock up all your binomials. Only factor your denominators, but lock up all your binomials. Okay. All right, so now I know that equals 15x minus 2, 15x minus 2, 15x minus 2. So my common denominator has been taken care of. I'm done with it. There is the form of my final answer, and I'm not going to keep writing it and dragging it along. Just write your numerator. Don't do any distribution mentally on the way. I can go ahead and do that as 25 minus 15x plus 3 times 3 plus 2x. Okay, I just I've lifted my numerator down and I'm going to clean it up. Kill parentheses, distribute, FOIL, combine like terms, and then check and see if you can factor before you stick it on the answer. X. Now that's correct. In a sense, you can actually factor this because if you have a leading negative, you could factor out a -1, right? Which would make that -1 times positive 9x minus 34. You didn't have to. This is correct. But I just want you to recognize with a leading negative, you can always factor out a -1, even if there was no other GCF. And so that means another way to write this would be pull that -1, just pull it out front, and it would be 9x minus 34 over 15 times x minus 2. Or you don't have to pull out that -1, but maybe you just don't like having that leading negative, so you might write it like this. 34 minus 9x. See, it's still positive 34 and -9. So you could just turn it around if you want, then you don't have that leading negative. It's still 15 times x minus 2. It does. All of these are mathematically correct. I just want you to recognize why they all are the same thing. That rule of -1. Okay? Yeah. Yeah. So my math lab would accept any of those. I would accept any of them. Just moving forward, the more you recognize that mathematical principle, the better. Because sometimes answers will look different. You're like, oh, I got it wrong. No, you didn't. If you got this and your neighbor got that and another neighbor got that, you all got the same answer. They can just be written slightly differently. Okay? (10 × x squared plus 5x minus 6 / x plus 2 / x plus 5. Now I want to make sure we get to everything today. So I'm actually going to walk through this one really quickly because I want to show you how that smoothness, that rhythm, and that organization helps. Okay? I notice I've got rational expressions and I've got plus and minus, so therefore I require common denominators, which I do not have. My next step is automatically going to be rewrite the problem with longer bars, and each denominator, every numerator that's complicated will be locked up. None of these need to be locked up. Definitely don't factor them, but at least lock them up if needed, not needed. And all of my denominators are going to be fully factored and locked up. X squared and 5x, that's a binomial. Oh, yeah, but it's got a GCF. They both have x's, so I just pull out an x. Don't be confused. This is not a quadratic trinomial. It does not require ACB. It is not a difference or sum of squares or cubes. It is just always, first question, GCF. I can pull out an x, leaving behind x plus 5. And that's it. Okay? This is, for some reason, a lot of people miss the GCF on those. You see that and you want to make it an ACB, but that's just for trinomials. This is a binomial. If you have a binomial with shared x's, then that x is going to come out first. And then this is linear, so there's nowhere further to go. And then minus 6 / x, nothing to lock up or factor there, plus 2 / nothing to factor here, but I'll lock up that x plus 5.
Aren't you doing the second one? Oh, that's the next step.
Not yet. Now that I'm going to go ahead and lengthen my bar, though. Okay. Oh, and I should, lengthen my bar. So now my LCD, I can see now my unique factors of x and x plus 5.
Okay.
This one already matches, so it's good. Nothing to change. This one requires an x plus 5 tacked on, so I'll do that on top too. And this requires an x tacked on, so I'll tack it on as top as well. My final answer has x times x plus 5. So I can set that LCD aside now and just bring down my numerator of 10 minus, that minus is entire numerator.
Okay.
So when I distribute that 6, I'm going to be distributing a -6. minus x plus 6 times x plus 5 plus 2x.
Can you just do that in your head? Like that's 4 plus 2? Oh, yeah, right?
If you do this step in your head, I see more careless mistakes, not you specifically, in general. That's why I always encourage, just bring your numerator down as you see it, and then start cleaning it up. Absolutely, the better you are at mental math, the more you practice, that's great. But for some reason, that mental math step, I see a lot of people, whether you're good at mental math or not, make mistakes. I make mistakes in that step for some reason. Okay? So it's just a hint. It's not required, but it's based on experience. Minus 6x minus 30 plus 2x. Let's see, I've got negative 4x and then minus 20. So kill the parentheses, clean it up. Oh, and I definitely have a GCF here. What should I pull out?
4.
Or, yeah, if you got a leading negative, go ahead and pull out the negative GCF. So that becomes negative 4 got pulled out, leaving behind positive x plus 5. Okay. So once you made the LCD match, set it aside, bring down your numerator, kill parentheses, combine like terms, and factor if possible. Once that has happened, you just put it on top. But before you walk away, hopefully your eye will see any factors of 1 that need to be canceled. Right, and that negative 4 that's on top, we'll just put that negative out front. Negative 4 over x.
Ooh, wow.
I don't understand how you got from.
I don't
the
either.
last step.
Me neither. I don't understand.
From here,
Yeah, from there to the.
She combined it like terms.
right here, from here to here, that's just factoring out a GCF. They have a 4 in common, 4 and 20. And because this was a negative in front, I decided to pull out the negative 4. Because your GCF, it can either be the positive or negative version. If your leading term is negative, generally pull out the negative GCF.
You have to?
Generally speaking, yeah. Because if I didn't pull out a negative 4, then these would not have matched. If I pulled out a positive 4, I would have, if I put out a positive 4, I have negative x minus 5.
After you divided it, so that's what you.
Yeah. Mhm.
Okay, so that's
Yeah, so when I divided out the negative 4, that left behind a positive x and a positive 5, which then matched this and could be canceled out. If I only pulled out a positive 4, I wouldn't have had matching binomials, and I could have fixed it, but it would have made more work, an extra step, sort of seeing that and fixing it. Okay. Good?
Okay, so all,
Why we get the minus 30?
money.
The minus 30 came from distributing this, negative 6x, negative 30. Yeah, you want to be real careful, especially when you got that subtraction in between that you are distributing, and you are distributing. That negative doesn't belong to the 6 or just to the x. It belongs to both parts.
I've got to get some color pencils.
All right.
Yes, ma'am.
Okay. At this point, here's my naggy side again. Is you have to practice. Okay. This is messy, chaotic, and overwhelming at first. I'm not going to lie about that. I'm not going to sugarcoat it. It does get easier with practice, with finding your organized strategy, staying clean and efficient, okay? Because that helps everything, whether it's simple or complex problem, follows these same mathematical rules and the same strategy you can use for every problem. But that's going to require practice and repetition for that to really sink in. Now, the next problems we're going to do are all about mixing these up. This takes us into actually working with complex fractions, which is 10.3. So let's start with this. Let's start with 2/3 minus 1 over x. Put that in parentheses. Divided by, parenthesis, 3 over x plus 1/2.
Okay.
Now we're mixing up our operations here. What operations does this one represent?
Divide, division,
And
multiplication, or subtraction.
adding, subtracting, yeah. So now we're mixing it up. Last week we focused on multiplication and division. Today we focused on adding, subtracting, and now we're mixing them up. When you mix up operations, you have to know what order to use your operations. Order of operations. Okay? PEMDAS. What comes first? Parentheses. We've got parentheses. You've got to clean up each parenthesis before you can deal with the division. You are not going to divide until this is cleaned up and that's cleaned up. And if you have two rationals in here, you're going to combine them into one rational. Combine this into one rational. You can combine two rationals into one rational with a common denominator. Okay? So you're going to do this subtraction and addition, and once you have a single rational divided by a single rational, then you will flip, factor, and simplify. Okay? So, now we can go up to the side, we can do our LCD and blah, 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 but these are some pretty basic common denominators, right? If we've got a 3 and an x, what is the LCD? 3x. 3 times x. They're already factored and clean, 3 times x. Okay, your LCD is just the product of those factors. So knowing that LCD, in this case, the LCD is 3x, how are we going to make this look like the LCD?
Sounds about pretty good.
This one times x, right? Be fair to the top. And this one times 3.
In this case, the LCD is 3 times x because it's other than the one word you told me and forgot.
It's 3 times x because the LCD is the product of the unique factors.
Mm-hmm.
There's nothing to factor here. This was a 3 and this was an x.
Other than 1, right?
Right, other than 1.
And you gave me a word.
Oh, the relatively prime.
Okay.
Right, but in this case, there's nothing, because you got a 3 and a 1. I mean, so 3 is your common.
Okay.
So if there were two numbers, like 3 and 5, then you would make it 15.
Okay.
But there's only one number, 3, and the other thing's an x. Right. Okay, so what's the LCD on this one?
X.
2x.
2x.
Okay, so make them match.
Can I ask you something?
Uh-huh.
Can I say, oh, you can't do that. That doesn't make sense. Never mind.
Answer your own question? Good. So I make the bottom match the LCD, and then whatever I had to do to make that happen, I did this exact same thing on top.
Okay. So you're gonna.
So now this is 2, not yet. This is 2, these are common denominator, 3x, and on top I have 2x minus 3. Divided by, I don't need the parentheses now because I changed it into a single rational. And here, I've got my single rational with 2x on the bottom, and my top is?
6 plus x.
Yes, 6 plus x. See if you're a person that does this when you're practicing your homework. And if you are, you're not alone. For some reason, the brain wants to do this. A lot of students do this. This is not 6x. This is not 6 times x. This is 6 plus x. A very common mistake is to write that as 6x. Okay? But it's not. Plus. This thing, this numerator, plus or minus this numerator. Okay? Now, I've got a division problem. Lock up any binomials. Okay? Flip first, then factor. It's not wrong to factor first, but then you often forget to flip, or you start canceling things out before you flip, and that just confuses things. So 2x minus 3 over 3x times 2x over 6 plus x, or x plus 6. Addition doesn't matter. My brain wants to make it x plus 6, but it doesn't matter either way. It either matches or it doesn't. Now, is there anything to factor? I've got 2 numerators, 2 denominators. Are all of them fully factored and linear, or is there anything I need to factor? Yeah, they're all linear and there's no GCFs. So, boom, I multiplied. Now, anything outside the binomials that can cancel? I look at the 2 over 3, is that in lowest terms? Yeah. What about x over x?
You want to cancel those? You can cancel.
Yeah. Yeah, it is. Because these are not terms, these are factors. See, there's no plus or minus next to them. It's not like x, that x, no. You can't cancel out those x's. That's outside the binomial, and this is locked up in the parentheses. See how that plus sign is touching the x? That makes this x a term. You can't cancel out terms. X plus 6, the whole thing goes or none of it goes.
So you can cancel out